Okay, welcome back. Now today we're going to start talking about something called the natural exponential. Okay, the number e. Okay, so we're going to derive the number e based on the compound interest formula. Okay, so in order to help us realize what this is, or to see how to do this, let's assume we take $1 and we put into an interest-bearing account. And we want to get 100% rate of return. Okay, so every year, right? It's 100%. Okay, so what would that look like? Well, let's plug it into our formula and see what we get. And we want to do it for 1 year. Okay, just over a 1 year period. So, if we do that, what do we get? We get, again, if we take our interest-bearing formula, A equals P times 1 plus R over N to the NT. Okay, now, so we're going to take $1, so that means P is 1, right? So P equals 1. And we're going to get 100% rate of return, which means R is 1. Okay? And we're going to go over 1 year. So that means T is 1. 1 year. So that means our formula will reduce to, or simplify to, 1 plus 1 over N to the nth power. Now, the question is what happens if we play around with N? In fact, what if, now, we know what happens if n is 1? If it's annual, we get 2 to the n. In this case, if we compound annually, this means that our money is going to double every year. What if we compound every semi-annually? That's going to be twice. That means that this is going to be compounded twice, and this will be 1.5 squared, right? And so the question is what happens if we make n? Because we can compound this weekly, or excuse me, we could do it quarterly, where n would be 4. We could do it monthly. We can do it weekly, we can do it daily, right? And so what happens if we keep increasing n? What happens if n, as n approaches infinity? Well, the thing is that as n approaches infinity, this approaches the number e. In fact, that's the definition of e. As n increases without bound, this expression approaches the irrational number e. In fact, e represents this as n approaches infinity. Okay? And so now, what we want to do is, for example, if I wanted to calculate e to the 3.14 rounded to 5 decimal places. Okay? So for example, now we can start talking about how do we, and again, this is called the natural exponential. So if I wanted to evaluate e to the 3.14 power, well, how would I do that? Well, there's a function on your calculator, e to the x. And so you can use the e to the x key by plugging it in, because your calculator takes this irrational number very much like pi. Pi is another irrational number. So you've got a pi key, you've also got an e to the x key. So you can find what this exponential is equal to. And so if you do that, you get approximately 23.10387. Okay, and so that's the approximate value of e raised to the power of 3.14. It'd be interesting to see what, because 3.14 is like pi, right? I wonder what e to the pi is. What do you get when you get e to the pi? So let me do this. Oops, let me clear. So I'm going to do e to the x, and I'm going to do, where's my pi key? Oh, there it is. So 23.14069. Okay, just curious. Okay. Now what about e to the negative 0.5? Ooh. What about e to the negative 0.5? So e to the negative 0.5. Well, again, you just do the same thing. Or you could look at that as 1 over e to the negative, e to the 0.5. But anyway, you could use the negative sign, the negative key on your calculator. So again, if I clear this and I do e to the x, and I put in negative 0.5, I get 0.60653. And that's it. Have a great day.